Hi, this session is about the continuous function. Let's solve a few problems. Before the problems, let's look at the definition. That means we can see that function f, it's called continuous function at the number a if the value of the function at a is exactly the same as limit as x approaches a of the function. So we can see if the limit is the same like the value, function is at this point is continuous function. We don't have any gaps, any asymptotes, any jumps. It's nice and smooth curve which I can draw the curve without lifting the pen from the paper. Of course, we have to always remember the meaning of the limit and the meaning of the exact value. However, they are the same. That means in order to find continuity, we always have to check a limit and the value. And of course, the value must be in the domain of the function. If the number a is not in the domain, then we don't even have to check. Okay, exercise number 1. Let f of x be a function defined as a x minus 1 squared just for values greater or equals to 1, and cx if x is less than 1. Find the value c that makes f continuous at x equals to 1. Okay, that means I can see this is polynomial, this is also polynomial, the first degree. Both of them are continuous function, but I want them to meet, I want them to have continuity at 1. That means based on the definition, I know that limit as x approaches 1 from the left hand side, and I have to choose, I can possibly draw a number line x 1, and if 1 is less than 1, function is called cx, that's left hand side. If x is greater than 1, the right hand side, function has a formula x minus 1 squared. That means the limit on the left hand side, which is cx, must be exactly the same like the limit on the right hand side, and I will put this formula. Also, value of the function must be the same. Value of the function, I will be using, for the value, I will be using this formula, x minus 1 squared, because we do have equal sign at this point. Okay, that's me. Let's try to find out. Limit on the left hand side will be c times 1, just c, and limit on the right hand side, I can substitute 1, and I will have 1 minus 1, 0, and 0 squared. I can possibly write this, and this will be the same like the value, which of course, if x is 1, we also have 0. Okay, that means c is equal to 0, because 1 minus 1 is 0, 0 squared is 0. And if c is 0, the value of the function at 1 is also 0, and the limits are 0, the left and the right hand side. Okay, that's me, nice and easy. I just use the direct substitution, but please note that's important, that's the definition. Okay, let's see the next question. For what value of the constant c is the function f continuous everywhere? And function is defined as a cx plus 117 for x less than or equal to 6, and cx squared minus 3 for x greater than 6. The same thing, I can draw a number line 6. On the left hand side, I have function defined cx plus 117. On the right hand side, I have function defined cx squared minus 3. And now both of the limits, they have to be the same. Value of the function will be defined as a cx plus 117 when x is 6, of course. That's mean definition of continuity. limit of the function as x approaches 6 from the left and function is defined cx plus 117 must be the same like the limit as x goes to 6 from the right hand side, cx squared minus 3. Okay, I see nice linear function on the left, quadratic function on the right hand side, no ratio, no zeros in the denominator. I have no problem, I can use just direct substitution. 6 times c, 6c plus 117, and then 6 squared, which will be 36c minus 3. Nice equation, we can solve for c. Subtracting 36 from both sides, I have 30c negative, and subtracting 117, I have 120. Dividing by negative 30, I think it's 4. That means c is 4. If c is 4, I mean I did answer the question, but let's just check one thing. I can select the answer, that means this is definitely the correct answer, but if c is 4, I can actually compute this limit. The left hand side limit will be 6 times 4 plus 117, and of course the right hand side limit will be 36 times 4 minus 3, which the left hand side is giving me a value. Okay, let's do the arithmetic. 24 plus 117, this will be 141, I think. That means this is limit, and let's see if it's the same like this one. 36 times 4, 30 times 4 is 120, because I don't have calculator, I have to manage, and 6 times 4 is 24. Let's see if I can do this way. 144 minus 3, it is 141. Excellent. That we can see the left and the right hand side is different, and this will be also the value at 6. It's the same calculation. Okay, but just in case if the question will ask for the exact limit, okay, that means the limit is 141, but the c value of course is 4. Okay, exercise number 3. Let the function be defined for x's greater than 2 as a ratio of square root of quantity 2x plus 5 minus square root of quantity x plus 7 all over the quantity x minus 2. And if x is 2, it's just the value k. Find the value k that makes function f continuous at 2. That means the same thing. I can see that my function now is defined on both sides at 2 as a first formula. That means the limit as x approaches 2 of 2x plus 5 square root minus square root of x plus 7 over x minus 2. Limit of the function must be the same like the value. And the value, we can see in order to use the value, to calculate the value is just simply k. That means the k value is the limit of the function. Let's see how we can solve the limit. That means what I will do my direct substitution. I have to be a little bit careful because I see the rational function and I may have a problem with the rational function. And we can see x, if I substitute 2, I am getting right away 0 in the denominator. And let's check. 2 times 2 is 4, 4 plus 5 is 9, square root of 9 is 3, minus 2 plus 7, 9, square root of 9, 3, 3 minus 3, it's also 0. That means I'm getting 0 over 0. Okay, that means we know that this is not really good sign. The only good thing about this ratio 0 over 0, it will tell me that I have a common factor from the function, from the numerator and denominator. Then I have to find this common factor, cancel out, and then possibly use the direct substitution. That's me. Let's try to work it out. Please remember, do not say 0. K is 0. That's really, really wrong. Okay, because 0 in the denominator is not really a 0. We can't divide by 0. It's undefined value. Because we can even see I can't substitute 0 because this function is not defined at 2. But I can definitely find the behavior close to 2. Okay, let's try. That means we do have a limit. That means I will try maybe to solve the limit on this side. Limit 2x plus 5 root x plus 7 root x minus 2. And we know that, and we have to simplify the root expression, we will multiply by the conjugate. 2x plus 5, the same quantity, but plus opposite sign. This means I will multiply and divide by the conjugate expression, of course, of the radical one. Okay, let's see what we can get. Okay, I will definitely distribute the conjugate, but I will not distribute x minus 2, which means in this case denominator. I will not distribute this because we remember x minus 2, it's my 0. That means I'm really looking for the same factor on the top. If I distribute x minus 2, I will spread out my 0 and I will never find out. Okay, how can I multiply the conjugate expression? We have one quantity. I can write a formula for you on the side. If we have a minus b and then a plus b, I can square the first quantity, square the second, and minus between them. Okay, that's what I will do. If I will square the square root of 2x plus 5, just 2x plus 5 will stay. And minus, and if I will square the second root, I will have just x plus 7. Okay, let's simplify. Limit. We do have to write a limit all the time. X minus 2, 2x plus 5. It's worth to rewrite because the common mistake is to forget about this expression. Okay, and what we have? I can possibly simplify on the top. 2x plus 5, distribute negative, minus x minus 7. And then 2x minus x is x. 5 minus 7 is negative 2. Excellent, I did found my 0. The 0 is gone. Now I can use the direct substitution. 2 times 2 plus 5 plus 2 plus 7, 4, 9, I think it's 3 plus 3. It is 1 over 6. That means this is the limit of the function at 2 as x approaches 2. That means this is 1 over 6 and this will become a value of k because that's the value of the function. Okay. So we can see, please remember 0 is not a good choice in this case. Okay. Exercise number 4. For what value of b is this function continuous everywhere? And what we have? We do have a function, piecewise defined function, and the situation is happening at 1 like that. On the left hand side, I do have the formula x squared plus ax. On the right hand side, for x greater than 1, I have 2x cubed minus 2ax plus 5, and exactly at 1 is just b, the value b. That means value at 1 is b. And we're looking for that b value. That means since my function is split for left and the right hand side, I have to find the limit first. Limit as x goes to 1 from the left hand side, and that's my function, must be exactly the same like the limit as x goes to 1 from the right hand side. 2x cubed minus 2ax plus 5. Okay. No rational function, just the polynomials. Let's substitute 1. 1 squared is 1, 1 times a is a. 1 cube is 1, 2, minus 2 times a times 1, 2a, and plus 5. Let's solve this equation. I can copy one more time, just to if I will add 2a to both sides, it's 3a, and if I will subtract 1 from both sides, 7 minus 1, 6. A is 2. Okay. However, it's not really my answer, because we're looking for the value of b. But what I know that the limit on the left must be the same like the limit on the right hand side, and must be the same like the value. Okay. Limit as x goes to 1 on the left hand side, the same like the limit on the right hand side, and the same like the value, which this is b. Okay, that's me. Let's find out what is the limit. What is the limit on the left hand side? What is the limit on the right hand side? And this will give me the value of b. I have the value of a, and I know that my limit on the left hand side, actually I was gonna point this, is defined as a 1 plus a. 1 plus a must be the same like the limit on the right hand side, 2 minus 2a plus 5. And I do have the value a. 1 plus 2, it's 3. 2 minus 2 times 3 is 6 plus 5. I'm really hoping I will get 3. Am I getting 3 or I am not getting 3? Oh, I do have mistake, because 2 times 2 is 4. Okay, that's me. Now I have 2 minus 4 is negative 2. Negative 2 plus 5, it is 3. Okay, because a, I can put one more time, a is 3. Okay. A is 2. Why? Because I have 3 the limit. A is 2. Okay, 1 plus 2 is 3. Okay, and the limit on the left, on the right hand side the same, and the value must be the same, and this is b. That's b. That means b is equal to 3. The same like the limits. And we do have this option. Okay, and I have another exercise. For what value of the constant c, the function is continuous everywhere, and we have piecewise defined function. This will be the left hand side, this will be the right hand side at 10. We have to check the situation at 10. That's me. Let's find out. Limit as x goes to 10 from the left hand side, I will use this formula, cx minus 14 must be exactly the same like limit as x goes to 10 from the right hand side. X minus 10 and square root of x minus 1 minus 3. Okay, and the value will be the same like first one, because we have the equal sign here. Okay, on the left hand side I can simply substitute 10 times c minus 14, but let's check, let's use the direct substitution. On the right hand side, 10 minus 10 is 0, and 10 minus 1 is 9. Square root of 9 is 3. 3 minus 3 is 0. Okay, I do have a problem. Please remember, do not assume that this is 0. Don't add 14 to both sides and divide by 10. That's not a good option. Okay, this is not 0. 0 over 0. It's not 0. Could be 0, but we really have to simplify and get rid of the 0 from the denominator. If we still have 0 on the top, that's 0, but at the moment it's not. But we know how to simplify this. We have to find this common factor. That's what I will do. I will focus on my limit on the right hand side at the moment. Okay, that's limit. Actually, I can solve it on the side and come back to my... Let's solve it here. A limit as x goes to 10 from the right hand side. X minus 10, x minus 1 minus 3. Simplifying the radical expression, I am multiplying and dividing by conjugate. Copy the first quantity, conjugate of the root expression. Copy the second quantity. If that was negative, this must be positive. Okay, and let's multiply. Limit as x goes to 10 from the right hand side. X minus 10, do not distribute this because we will x minus 10 is my 0 and I really want to cancel out. And then I have to square the first quantity. Squaring root of x minus 1 is just x minus 1, and minus, and squaring 3, I have 9. And actually x minus 1 minus 9, something is, oh no, it is negative 10, okay. I was looking, I mean, I don't have to, let me simplify this. That means this is x minus 10 and this is x minus 10. And because I can write it's x minus 10. That means that's my 0, it's gone. And now I can use the direct substitution. I only have square root of x minus 1, which is 10 minus 1, plus 3. Square root of 9, it's 3, 3 plus 3 is 6. Okay, that means this limit we can see. I can erase this, it's not 0, the limit is 6. And then I can solve for c. Adding 14 and dividing by 10, the value is actually 2. Okay, that means please remember, do not assume that the direct substitution 0 over 0, because that's always the main confusion. Okay, and I do have one more, really similar, almost the same. Find the value of the constant c for the function to be continuous everywhere. I'm not really, reading the exact text. Okay, the same situation. We have to find the constant c for both of the function to have the limit at 3 the same. That means we have a function defined for x less than 3. This is the left hand side. Okay, and for x greater than 3 is the right hand side. That means limit as x goes to 3 on the left hand side. We do have a function just square root of c, which is constant, and limit, let me move a little bit, then I can probably squeeze my solution. Limit as x goes to 3 from the left hand side must be the same like a limit as x goes to 3 from the right hand side, and this is my function root of x plus 1 minus 2 x minus 3. Okay, that's mean limit of the constant is simply a constant, no problem on the left hand side, but on the right hand side, let's see. 3 minus 3, I can see right away, is 0, and 3 plus 1 is 4, square root of 4 is 2, 2 minus 2 is 0. Okay, again, similar situation, 0 over 0. We know that it's not 0. Please remember, I can maybe write somewhere 0 over 0, but the answer is not 0. And we know what to do. We will multiply and divide by the conjugate. That means I will focus on my limit plus x plus 1 square root 2n plus, because that was minus, this must be the opposite sign. Okay, and let's distribute the conjugate, but do not distribute the denominator. Okay, that's mean limit as x goes to 3 from the right hand side. I will copy one more time my denominator. Okay, and then distributing, foiling the top function, I have to square the first quantity, x plus 1, the square root is gone, minus square the second. Squaring 2 is 4. And you may notice plus 1 minus 4 is giving me minus 3. That means I see my common factor, my common 0, x minus 3, x minus 3. It's gone. That means the limit is now equals to 1 on the top, and I can substitute 3. Square root of 3 plus 1 is 4. 2 plus square root of 4 is 2. 2 plus 2 is 4. Okay, now in order to solve this, I have to square. I have to square both sides because I have to get rid of the square root. Squaring square root of c squaring is just c, assuming that c is positive, but I think c is positive. And squaring 1/4 is 1 over 16. Not plus or minus, because I didn't take the square root. Okay, that means 1 over 16 is the final answer. And we can even notice, because c is under the square root, that means we can't really have negative numbers. Right? We have to have a positive number if we want the real solution.